Hello everyone. In this question, it is given that if log 4 base 2, log 8 base square root 2, and log 9 raised to the power k minus 1 to the base 3 be three consecutive terms of a geometric progression, then we have to find the number of integers which satisfies the inequalities x square minus x greater than 6 and mod x is less than k square. Okay, so we have to find the value of k first from this given condition that these three terms are in GP. Okay, then we have to find the number of integral solutions which satisfies both of these inequalities. Okay, so let us start here. We are given the terms log 4 base 2, log 8 to the base square root 2, and log of 9 raised to the power k minus 1 to the base 3 are consecutive terms of GP. Okay, so these are in GP. So if I simplify their values individually, okay, this value, this is nothing but log 2 square to the base 2, right? So if this 2 in the power will come here and this becomes log 2 base 2. So this is equal to 2, right? Similarly, the second term here, this can be modified as 8 can be written as 2 cube, and this base square root 2, this is 2 raised to the power half, right? So this simplifies to 3 upon half log of 2 base 2, right? This is the formula, right? Since the this power here, the logarithm of 8 is 2 cube, this power comes in the numerator of the fraction, and the power of the base, that is 2 to the power half, this comes in the denominator of the fraction, and the log 2 and these two are kept separate, right? This is the formula. The formula is if log of x to the power m to the base y to the power n. Okay, this is the formula that I'm using here. This is m upon n of log x base y. Okay, this is what I have used here. Okay, so this now becomes 3 upon half is 6, and this log 2 upon 2, this is 1 again. Okay, so this is the second term. Similarly, if I try this third term here, okay, I'm doing it a bit uh, below the others. Okay, this is nothing but again log 3 to the power, this 9 is 3 square, right? So this 2 will multiply with this k minus 1, so this becomes 2k minus 2 to the base 3, which then just becomes 2k minus 2, and log 3 base 3 will become 1, right? So the terms now become 2, 6, and 2k minus 2 are in GP, right? So these are the three terms which are in GP. So this implies that the square of the middle term, that is 6 square, will be equal to the product of the other two terms, right? 2k minus 2. So from here, this is 36. 36 upon 2, this will become 18. So 18 will be equal to 2k minus 2. So this implies that k will be equal to this 18, and 2 goes to the other side, so this becomes 20. 20 upon 2, so this means k is 10. Okay, so we have found the value of k. K is equal to 10 here. Now we have to find the number of integers which satisfies both these inequalities. Okay, so the first inequality is x square minus x is greater than 6. So this simplifies to x square minus x minus 6 is greater than 0. So this on factorizing becomes x minus 3 times x plus 2, right? Minus 3x plus 2x, so minus 6, and product is minus 6, is greater than 0. So this can be written again as x minus 3 times x minus of minus 2 is positive. Okay, so this implies that x has to be smaller than the smaller number. The smaller number here between 3 and minus 2 is minus 2, right? So this lies between, this is smaller than the smaller number, that is it goes from minus infinity to minus 2, since it is a strict inequality here, and has to be larger than the larger number, which is 3 in this case. Okay, so this is the first condition where x is integer. Okay, this is the first condition. The other condition is mod x has to be less than k square. So if mod x is less than k square, this implies that x lies between minus k square and plus k square, right? So the value of k was 10, right? So this becomes minus 100 less than x less than 100, right? So this implies that x lies between the open interval minus 100 to 100. This is the second condition where x is an integer. Okay, so we have to find the common solutions which satisfies both. Okay, so we have to take the intersection. Taking intersection of 1 and 2, here it was going from minus infinity and it was stopping at minus 2. Okay, minus 2 is excluded here, but it was stopping at minus 2. But here it is given that the solution ranges between minus 100 to 100. So if we look at the negative bounds, this goes from minus 100 up to minus 2, and similarly for the positive bound, it starts at 3 from the right hand side and goes up to 100, right? So it starts from 3 and goes up to 100. Again, x has to be an integer here. Okay, so this is the total solution set. So now we have to find how many integers are here. So in the first bracket here, if we start from minus 1 up to 100, minus 100, there will be 100, right? But we are excluding the values minus 100, minus 2, and minus 1, right? These are discarded. These three integers are not there. So this is equal to 100. There are total 100 integers if these three were included in the set, right? Since these three are excluded, this is going to be 100 minus 3. So we are getting 97 integers from this first part. Okay. Similarly, in the second part, 3 and 100 are excluded, which means the numbers 1, 2, 3, and 100 are discarded, right? These are not present here. Okay. These are to be discarded. So this is, if these four were included, it would have been 100, right? But since these four are discarded, there are 96 integers in this set, and 97 in the first part. Okay, so total integral solutions will be the sum of both these parts, right? So this is equal to 193. So this is the required final answer. Okay, these are the total number of integral solutions which satisfies both of these given conditions. Okay, so this was the final required answer here. We have to solve for both of these inequalities, and firstly we have to solve for this logarithmic part. Okay, this is the only part that you have to know this formula. If you know this formula, this becomes very easy. Otherwise also you can do it as a power of root 2. Okay, you can write 8 as square root 2 raised to the power 6. So in that way also you can solve it without using this formula. Okay, the other parts are very easy to solve here. There isn't very much required here. Okay, so this is it. Thank you for watching.